All right, we are going to solve systems of linear inequalities by graphing. This one is a doozy, okay? Because here's the thing. It's just like topic 3, which was kind of hard, but twice. We're just going to do it twice. Same as this one was kind of like topic 1 times 2. This one is kind of like topic 3 times 2, okay? I would recommend color while you take notes and a ruler while you take notes, okay? So what I have is I have a ruler and I have 2 different colors that I'm going to use on my notes. You might want it for your notes as well. Okay, let's take a look. I'm going to first graph this line, and then I'm going to graph this line, and we're going to see where they overlap. That is where the solutions to this system are. So first, y is less than 2. So in order to graph this line, I'm going to think, where are some points where y is 2? So like 0, 2, 3, 2. Those are both points where y is 2, so like here and here. So I realize that line y equals 2 is here. Now, because it's a less than symbol, and there's no or equal to, I'm going to draw this as a dashed line. And because it's less than, I'm shading down. Now notice when I shade, I'm shading with lines coming directly away from the line. Okay, now this one. X is less than or equal to -1. So first let's find where the line x equals -1 is. So like here's a point where x is -1. Here's another point where x is -1. So -1, 2 is here, -1, 4 is here. Okay, so I can see this line is here. It's or equal to, so I'm going to draw it solid. Okay, notice I'm using a ruler. I'm going to draw a solid line. Okay, and then this is less than. So because it's less than, I'm shading either down or left. So in this case, I'm shading here. Okay, now here's the thing. The solution to this system of inequalities is any point here. This is where the solution is. Okay, so like any point, like if I plugged in, let's say -3, -2, and I plugged it in, it would be a solution. If I plugged in -2, -4, it would be a solution. If I plugged in a point over here, it would not be. Even over here, it would not be. If I plugged in this point, it would be a solution to the orange equation, but not to the blue one. If I plugged in a point over here, it would be a solution to the blue equation, but not to the orange one. If I wanted a point that was a solution to both equations, I'd have to come over here where they overlap. Okay? Let's look at a different one where we have 2 slanted lines. I'm going to start with graphing this, right? Y-intercept is 5. Slope is -4. I'm going to go, let's see, down 4, left, the right 1. Okay, I notice this is or equal to, so I'm going to draw a solid line. Okay, now am I shading up or down? I see that it's a less than sign, so I'm shading down. I'm shading this way. Okay, next line. I'm going to start at -1. My slope is 3. 0.3. I see that this doesn't have an or equal to sign underneath, so I'm going to make it dotted. Or dash, excuse me. Which way am I shading? This is a greater than sign, so I'm going to shade up. Okay, so my solution to this set of inequalities is here. Okay, it's these points. Any of these points I could plug into either of these equations and they'd be solutions. Over here, that would be a solution to the blue equation but not the orange. Over here, that would be a solution to the orange equation but not the blue. And over here, that would be a solution to neither of the equations. Okay, I would encourage you to watch the tutorial on this one as well because it's challenging. Okay.